Okay, so some years ago, I gave a little talk on variable star observing. I was sort of hoping to stimulate a few people to do a little bit of it. Uh, I wasn't successful. uh, so I thought the time had come to try again. Uh, What was I? Well, I didn't know that. Okay, now he says he did too. Oh, all right. So another try. Maybe we'll get some more. Uh, before we get into variable stars, I just wanted to back up a little bit and have us think about just how fundamental stars are in general. Think about a universe in which there was no fusion, just a great void with some hydrogen in it that had no ability to do anything, just clump up. Everything's dark matter. Stars are everything. Stars light the universe. Stars make all the matter uh, denser than hydrogen. On this planet, star fuels life, and it's hard to imagine that you could have life without a star. Stars are it. And so anything that deals with stars has fundamental significance. Now, briefly, we're going to, in this little talk, we're going to learn how variable stars triggered a renaissance in astronomy. We're going to learn how variable stars and the observation and study of variable stars birthed the first and one of the most robust, if not the most robust, citizen science organization that exists, the American Association of Variable Star Observers. We're going to touch on why we study variable stars. And finally, I hope the real meat of the nut, which will actually be pretty brief, who can and how to become an amateur variable star observer. Now, we'll dispense very quickly with the why observe variable stars. I already touched on how important stars are, right? But beyond that, variable stars in particular have been the sort of the original accelerator, in natural accelerator in the sky, because understanding variable stars and what makes them happen gets you inherently into the physics of the atom. And so they're natural laboratories. They are the means by when one of the principal means for measuring interstellar distances, still used, still an important element there. They are an insight into stellar life cycle and evolution. We can't watch a star through its whole life cycle, but we can catch individual stars. That's largely what makes variable stars. A big part of it is where they are in their life cycle. So by studying variable stars, we can come to understand the life cycle of stars. And finally, in these days, it's a potential source for exploring the potential for extraterrestrial life. And that's with the transits, planetary transits. Now, this is a mechanism dated around 100 to 200 BC, the Antikytherian mechanism. Did I pronounce that reasonably well? This was discovered on the bottom of the Mediterranean. It's an extremely intricate brass geared device to predict the motion of the planets, the moons, and the stars. The fact that they had the ability back then to machine this device was amazing. But I bring it up because this sort of represents a point in time in which astronomy comes to a dead end. After this period of time, humanity had studied the motion of the skies well enough that they could predict these things with reasonable accuracy. They didn't understand why the planets did what they did. They only knew how to predict it. But Ptolemy had cataloged the brightest stars, the constellations he had charted. They had this kind of knowledge about predicting the motions, but what else could you do? With their technology, you couldn't do anything. And so for the next 1,500 years, astronomy just stagnates, at least in the Western world, as a practical matter. Almost nothing happens. And in fact, the astronomical point of view when we jump forward where we're going to the 16th century, was that the universe, we knew everything you could know about the universe from the Bible and Aristotle and Ptolemy. That was it. And if you were interested in astronomy, what you did is you studied those theories and read the Bible, and that the universe was immutable, never changing. And that was the view, and then that was the view, was one reason astronomy was going nowhere. Until this gentleman comes along, Tycho Brahe, 1572. Now, Tycho is an interesting character. He was an upper middle class, probably, maybe you could say a little better than that kid, and his dad sent him off to university to become a lawyer. You know, worthy occupation. But there were some big astronomical events that were sort of buzzing around, an anticipated eclipse. As I recall right, I should have looked this back up to refresh my memory. And maybe a lunar transit or something like that. And he noticed they just weren't that accurate. And he became obsessed. And he became a professional astronomer. And one of the early concepts of a professional astronomer was Tycho Brahe, unless you count the priests from way back when, the astrologies. But he dedicated his life. He just knew that the way to solve these problems and to get these motions of the planets down better was you just had to measure everything better than it had ever been measured before. And so he became, his task was to refine the positions of the stars and to track the planets and all that. Well, a supernova happens in 1572, and he sees it, and he documents it, and he publishes his finding and proves that it was a new star. Well, that was a big deal, because in a world in which the universe was immutable, a new star was ground shaking, cosmologically speaking. And this kicks off a new open mind. Now, you know, it kicks off a new interest in observational astronomy, and you can then track this and how it picks up steam over time, because it just opened the mind that once again, it was worthwhile to study the night sky. And one evidence of that is Uranometria, Johann Bayer's compilation of the 1,564 of the brightest stars, and they're making a atlas, star atlas in 1603, I believe. I did fail to put that on here, so I wouldn't need a note. But 1603, he creates this atlas, and he uses Tycho's data that Tycho had compiled, Ptolemy's constellations, and some other sources to come up with his 1500. And he, as everybody in here probably knows, he's the originator of the Greek alphabet naming system that still is prominent in naming stars today, where you use a Greek letter in the constellation the star is in, usually alpha being the brightest and going down through the Greek alphabet. He's the originator of that. In his original work, he goes on down into the Roman alphabet some too. That doesn't get used much anymore. Well, why is this showing interest? Well, there are still 100 copies of this, of the original printing of this, still in existence. Now, if there was 100 copies of them still in existence, how many were originally printed? A goodly number. And then there were 4 more editions after this. And how many professional astronomers were there in the world, you think, back then? These were amateurs buying these sky watchers like us in this room who were buying these charts. And lo and behold, what happens? Well, the very first variable star, besides supernovas, discovered, and setting aside Algol, which seems to have been documented back by the Egyptians 4 or 5 millennia back from here, is discovered by a German preacher, an amateur sky watcher. And in 1596, he sees Mira where he does not expect to see a star. And he just writes it off as another supernova, like Tycho's, right? Well, jump forward to 1609. Now, the telescope was invented in 1608. Galileo turns it on the sky famously in 1609 and sees, of course, the church's view, the prevailing view was the moon was this polished orb, this pearl in the sky, celestial perfection. He puts the telescope on it, and hell, it's a terrestrial body. And he turns on Saturn and he sees it's got moons. And he realizes it's just a planet. Earth is a planet. So these are eye-opening event happening in 6, but that's sort of a diversion here. But because David Fabricius here, who viewed Mira in 1596, he's got a telescope in 1609. 1 year after it's invented, he's got a telescope, and he sees Mira in that telescope when it's not visible to the naked eye. And he realizes that that star is variable. So that's the first one. I got some notes down here. Johannes Holloward, we'll run into him again in a minute. He figures out that Mira has got an 11-year cycle in 1638. Algol is rediscovered by Western science in 1669. Chi Cygni is discovered in 1686. R Hydra in 1704. And by 1786, there are 10 variable stars known. And the pace of discovery is getting ready to explode. Now, we all know William Herschel and his sister, Carolyn, probably the ultimate amateur astronomers of all time, arduous recorders of sky objects of all sorts. Well, his son, Sir John Herschel, followed in his footsteps, made a career of astronomy. And he publishes in 1833 an edition, a treatise on astronomy. And in it, he says, this is a branch of practical astronomy that has been too little followed up, and is precisely that in which amateurs of the science, provided only good eyes or a modest instruments, might employ time to excellent advantage. And I'll just say right now, it's still true. A pair of good eyes or a pair of binoculars or a modest instrument, and you can still do variable star observing and contribute it to the science body of science and be credited for it, as we will see. So he encourages this. Once again, I'm just going to use charts for Mira in all of this. You go on to the AAVSO, the American Association of Variable Star Observers, that we're going to talk about the birth of here in a little bit, which is fundamentally an origin, an amateur organization, and it's still, they say they bring amateurs and professionals together. They record all this data that they can gather from way back when. And if you go out tonight and were to observe a variable star and turn that in, it would go in their record and would go in their record under your name. And you can go in and research, pull up the star, pull up an observer, and see the data that exists from, as I say, for a given star over a given period of time, or from a given observer. And this is the star that Fabricius first sees in 1596, Mira. And here are his observations here, and then later with the telescope there. Then I mentioned to you Halwarda, who figures out the period. Here are his observations. And then I just grabbed this guy, Johannes Hevelius, because he was sort of the next and observed it over about a period of 30 years, arduously observing Mira and probably other stars as well. And you can see, you just come down here and click on his His observer code is HVJ. He's got 152 observations in this time frame of this star. Now, he's most noted because he first did an atlas of the moon. He charted a moon in the 17th century. He was a mayor of Danzig, another amateur, and those charts of the moon were the first published. They published after his death. But you can see all this going on, and I don't know why this gap is here. That would be an interesting little historical deal. But you can see that Sir John Herschel calls for more amateur involvement in variable star observation. And when the record picks up again, you can see it's a whole lot different than it was, much denser. Now, a German astronomer, Arlinger, I don't know why I'm suddenly drawing a problem with that. He comes along, he's really sort of the dean of variable star observing, to tell you the truth. And he invents the scheme by which we name variable stars. He makes another call to amateurs to become involved in 1844. But it's Edward Pickering that really sets the ball rolling for the what leads to the American Association of Variable Star Observers. He was the director of the Harvard Observatory, and he was obviously very interested in the variable stars, understanding how important understanding them could be to advancing astronomy. And he also realized there were a hell of a lot more variable stars than there were professional astronomers. He needed data, and their stars were out there. What to do? Well, he publishes a plan for securing observations of variable stars. And he basically says to, like Herschel and Arlinger, I know I'm pronouncing that wrong, before him, calls for amateurs to become involved in observing stars, but he does one thing more. He says, send the data to me. Send the data to me, and I'll collect this data. We'll catalog, we'll archive this data, and I can analyze it. And so he kicks this ball off in 1882. And so you just come in here, and I should have gone a little longer than 1907 because his project goes on until it gets actually taken over by somebody else in 1911. But you can see, again, this is just Mira. The observations that are now in the record that were gathered during this time frame after he had made his appeal. Now, in this case, I just picked out Thomas Blackhouse here, and I did it because he had so many observations. And I say, Google it. That's what I did with these other guys too, by the way. Google Thomas Blackhouse. Well, up comes an obituary notice from the Royal Astronomy Society in Britain announcing that he's passed away, and it describes his activities a little bit. He had a 4 1/4 inch Cook refractor in a personal observatory in his home place, and I forget how many observations they credited him with over years. But my point is that if he were here tonight and you could talk to him, it would be the same kind of conversation that any of us have about his telescope and what it does and what it doesn't do and what he does with it and so forth. A kindred spirit. And here he is, his data, eternally here, and also noted, as I say, in his obituary. Now, in that picture, I couldn't show you all the observers, but up through 1907, there were 56 individuals contributing to that data. And altogether, there were 3,581 observations of just Mira. So you can see how successful, and the bulk of these people are going to be amateurs. And just another example, David Flannery. Flannery's an Irishman. He immigrates to the United States in 1845, takes up a residence in Jackson, Mississippi. And then in 1895, he gets the bug, variable star bug. He makes 44,000 observations of 80 stars in the next 5 years of his life. And his little note, and here it is, recorded right here of Mira. And in his little notebook, he notes that he's basically not supposed to be out of bed. He's on his deathbed, but he sneaks down to a few steps, a few flights of a few step levels, so he can look out the window at his favorite variable star, which I can't remember which one it is right now. But I point that out because if you start doing this, and you don't have to give up anything else you're doing, you just add a variable star or two to your observing program and start recording them and turning them in. And over time, you get to know that star and its comparison stars. We'll talk about how this is done, that you use to judge its magnitude. You get to know those. And when you go to look at it, it's like you're going to see an old friend and you're curious to catch up on what SS Cygni or whatever it is doing tonight. And that's what he was evidencing. Now, Pickering, now remember, he called for this in 1882. In 1891, he decided, boy, I'm going to help these guys out. We need more data. We need more amateurs, and to make it, we need to make it simpler. And so what he did, he started providing sequences. Well, sequences is nothing more than the list of stars that you use to judge the magnitude. And we'll talk about how that happens in a minute. So he started sending out, if you wanted to observe a certain star, he'd send you the sequence of comparison stars to use for that. And then in 1906, he decides to do even better than that. And he starts creating these charts. Now, this is still the way it's done today if you do variable work. But when I first did my variable star observing back in 1991, I believe it was, you had to, I believe you sent in a self-addressed stamped envelope and told them what charts you wanted, and they would mail you the charts. Well, of course, you don't do that anymore. Huh? Yeah, maybe you did. I don't really recall. And then you would record your things on paper. You know, you'd record your things on paper and mail them back in. But basically, you've got these stars with numbers beside them are your comparison stars. And this is your variable you're trying to study. And this star 103 is a 10.3 magnitude star. You just take the decimal, put the decimal point in there. They have obviously had to take the decimal point out because otherwise they'd look like a star, right? So there are no decimal points, but this is 10th magnitude. That's 10.3, 6.1, 4.8, 9.0, etc. And you just get your variable and you say, well, it's brighter than that one. It's dimmer than this one. And you work until you get it bracketed between two stars. If it's brighter than one and dimmer than the other. And then you say, well, okay, is it halfway between? Is it 3/4 of the way between? And so forth. That's how it works. And you'd be surprised how accurate that can be made when multiple observations are turned in by different people. You do a statistical kind of averaging on it, and they get tremendously accurate results. Now, so William Tyler Alcott, this got to where it was overwhelming Pickering. I think he took in like 6,000 observations from the time he made those charts available in 06 to 9/11. And he was being overwhelmed with the process of getting these things out and recording the data and everything. And one of his observers, William Tyler Alcott, volunteered to take that process off his hands. And he wrote into the Popular Astronomy that he would correspond with anybody that was interested in observing variable stars. And that basically is the beginning of the American Association of Variable Star Observers. All right. So today, you take Mira and you look at it, and there are 92,000 observations on record from 2,400 observers, and people are still turning in observations. Now, you see the color here on the end. That's where digital stuff starts coming in, various kinds of digital photometry. But that does not mean you shouldn't do visual observing. They still want visual observations. Visual observations still value, and they help to maintain the continuity of the record over time. And you can see how dense these records have become. Now, today, the AVSO is the depository for variable star data. I don't think there is another serious depository out there. At the moment, they've recorded, as of about a week or so ago when I was working on this, 64 million observations. Some of those these days are coming from the automated surveys. You know, they're pouring data in. I'll touch on that in a minute. They've got about 900 active observers, most of whom are going to be amateurs, turning in data. Now, so that's the sort of the AAVSO story. What I want to do is, you all know I'm a lawyer. I'm not a geeky guy, and yet I can do this. So if I can do it, you can do it. Anybody in here that can do the Messier list can start observing variable stars. And anybody in here who can make these beautiful photographs that people make could do photometry. It's, in fact, a lot easier. But I just want to touch on my personal activity here so you can see that this is approachable to you. This is from my first 2 years when I was doing visual work before I dropped out of the hobby for a time, which is another story. Diversion from here we don't get into. To tell you the truth, if I had some open sky in my back of my yard, I'd still be doing the visual in addition to what I'm doing photometrically, but I'd still be doing the visual. It's just a lot more rewarding. Like I said a while ago, you get to know these stars, and you get to where you can just put the telescope right on it, and then there's that friendly field of view that you know well, and you can make your estimate. You're doing it with your eyeballs, and you're out under the sky. It's a whole lot more fun than processing this data. But at any rate, this is a 2-year time period basically, and this is other people's data mostly, but mine, if you can make it out, are the little blue specks in here. And it's most satisfying to see that it fits right in with everybody else's data pretty well. And that's the other fun thing about this. When you turn in, then you get to go look at your data and see it. So you go on the website just to familiarize you a little bit with how easy this is. First of all, they've got this tab, new observers start here. You can't beat that. You ask for a code, they give you a code. I don't think you have to be a member. You didn't used to have to do. They got all this how-to information over here on all kinds of different ways of observing and different kinds of observation processes. They've got a thing here on what you should observe. And then this is the meat of the nut up here. This is where you click on that to turn your observations in these days. It's all done digitally, of course, online. This is a catalog of variable stars. Essentially every variable star is known to exist is now in that catalog. I'm trying to remember how many thousands, tens of thousands of stars. I think it's, I want to hazard a guess, but let's put it this way. The new general catalog of variable stars is 60,000, and it's a tiny little thing compared to the AVSO's catalog now, which is run by one professional and 10 volunteers, as I understand it. And the VSX, that's what I was just talking about. This is a program where you can either your data or somebody else's data that you can download off the site. You can plug it in here and do statistical analysis on it. I've actually been able to do some of that. I made a C in statistics in college. It's pretty simple to run. This is where you get your charts. This is where you can process photometry, including done with DSLR cameras. And then this is where you can see the data like I've been showing you. Yes, sir. Well, I don't know for sure what that answer is, but I'll show you something in a minute that'll sort of answer it. Okay, I think. All right, this is just a typical chart of what this looks like. I've already showed you the ones when they were hand drawn them back in 11. They were hand drawn them. They're obviously computer generated now, but it's the same kind of. This is a sequence. So each of these comparison stars has got a name and right ascension declination, the label magnitude, and the actual V and B minus V color of the star. Just a picture that shows how a variable star can change in the way it might look. This is how you enter your observations. And then, like I say, once you do that, you can come back here and look and see your own observations. Now, I think this is going to answer your question. So when I got back into the hobby, I determined that I was going to get back in the variable star business, and I was going to get this robotic system set up, and I was going to do photometry. This is the first star. This is the first. I ran a time series on a cataclysmic variable. This is 6 hours. It's about 6 hours of data. So I think you were asking me how fast can it vary? And this is over a course of 6 hours. You've gone from almost 10.9 down to 10.5. So 4/10 of a magnitude in 6 hours. It can be a lively activity sometimes. That's not typical. Now, so now I'm gonna brag a little bit, but again, in the interest of saying, hell, if I can do this, you can do it. In my photometry, I use a computer program to process the data, right? And then I do a little quality control thing that I've made up myself, and to look and make sure that the comparison stars are behaving themselves. That they, in fact, comparison stars are supposed to be stable. See, and occasionally I have found a comparison star that didn't look right. And this was fairly early on. I discovered this one, and it turned out to be an eclipsing binary. So now I'm in the VESX catalog as the discoverer of this, and that's a pretty heady deal. You can go on there and James Bruce McMath, discover of this eclipsing binary. Eclipsing binaries are pretty important and fairly rare objects, by the way, because you can use they allow you to actually calculate the mass and temperature and all these other factors of the star. And then in some other cases, I think I also discovered an Uxor, but that was a known variable. It just wasn't known what it was. And then in 4 or 5 cases, I've been able to turn in data to show that a star was not properly classified. And this is one of them. Now, this is something I won't really, I bring this up primarily to note this. This is the data on the same star as my data taken from the Northern Sky Variable Star Survey. So they've got these surveys going. You might say, why would I bother to do photometry? They've got these surveys going that survey the whole damn sky, at a clip and a huge database of data. The problem is, once again, there are more stars and more data than there are people to process it. So this star's nature was already out there in this database from the Sky Survey, but nobody knew it and so this is another thing you can do. Maybe you're like me, you just got trees all over you can't observe. If you're interested, you can get in and access this data and start processing this. And some people do. All they do is process the data and discover the nature of or discover the variability of stars. Now, this is what it looks like this is for that V0353 LAC that I just showed you the data on. If you go into the VSX and look at it, then this is where you I get to see my name, see, submitted here. on this date, and the supporting documentation is my phase plot, and so forth. There's a couple other references down here. So that's heady. And then, even if you don't do anything like that, just turn in your data. People access that data. They give you a report every week. You get a report from the AVSO if someone accessed some of the data you generated. And so this is a report I got at some point, and people downloaded my data along with other people's data, undoubtedly, on these stars in a certain August 28th, 2015. This is from that old slideshow, okay, some years ago, so I didn't bother to update it. So now, in addition, there's a community. If you get into this, you want to get in, you can tap the community. They've got these forums on all kinds of different topics. Some of them just basic how to do this, but other issues. And I think you have to be a member to do this, but you can participate in the forums. They've got a mentoring program, and I will, of course, be happy to mentor anybody that's interested in doing this right here. And it's a highly varied area. You can go in here. I do pre-main sequence stars. That's what my interest is. But there are all kinds of variables, and you just pick out one area that you're interested in and start learning about it, pick you out some stars, start observing them, and turn them in. It's as simple as that. And as I say, anybody can do it, and it's rewarding. That's it. End of my slideshow. Well, sure. Hopefully, it'll be on Zoom. It'll be on our YouTube channel. Oh yeah, no, I can figure out a way to post that. Yeah. All right. Thanks.
To hang things like these nice plaques. That one has names on it. And there's been an idea about the astrophoto of the year done by members and things like that. So if anybody has any suggestions about that or thoughts or comments, please catch up with me just after the club meeting here this evening. And thank you.
With new ideas, business, etc. Guys, and everyone, please remember the Dark Sky Festival coming up month. Last year, great.
Thanks for everybody for coming to cast, and we'll see y'all next time.